We're going to take a look at a couple special cases of linear functions as well as an application example. So the first special case is the constant function where f of x is equal to k, which is some constant or a fixed number. For example, I can let f of x be my garbage bill, which is $24 a month, so I'll just let that equal 24. And I can let x equal to the number of pounds of garbage. And even though x is a variable, so from month to month, the number of pounds of garbage changes, the bill is still exactly the same. It's $24. And so it's a constant function. The y, or the output value, is always the same. Another special case is the identity function f of x is equal to x. And again, if you prefer to think of f of x as being y, you can write this equation as y is equal to x. And that's a straight line that increases with a slope of 1. And what we're saying is the output y is the same as the input x. And so, for example, a matching grant would be an application of this. If I donate a certain amount of money, so let's x be the amount of money that I donate, then if f of x is the amount of money that the philanthropist, say Bill Gates, decides to donate, f of x is equal to x. That means if I donate $10, then f of x, again, the philanthropist contribution will also be $10. And if my donation is $100, the philanthropist also will donate $100. So let's take a look at another application. In this example, we have a facility rents for $200 and charges $15 per meal, and it's represented by this linear function. So the cost of hosting, say, a banquet is going to be the flat rate of $200 plus $15 times the number of guests. And it asks us to calculate some ordered pairs and to graph the function. So I'm going to make a table here with x and c of x, and you can think of c of x as being the y value. But we'll calculate the cost for a number of input values. So, for example, if there are no guests, 0 guests, the cost of having 0 guests is going to be $200 flat rate, but there will be no variable cost because it'll be 15 times 0. And so the cost of hosting 0 guests is still $200 just to pay for the facility. If I were to have more guests, suppose I had 100, so we'll calculate cost of 100 guests, C of 100. This would be the initial $200 for the rental of the facility, but plus $15 times our 100 guests. So we end up with $1,500 plus the 200 is going to give us $1,700. And again, that's for an x value of 100. And if you wanted to have a larger event with 200 people, we can plug in that number. And so the cost of 200 people is going to be the initial $200 facility rental plus 15 times 200. And that comes out to be 15 times 2 gives us 30 and 100, so that's $3,000. But 3,000 plus 200 gives us 3,200. So now we have 3 ordered pairs that we can use to plot. And on our x-axis, from the values that we've chosen, we go between 0 and 200. So I've got 0 here, and then I'll put hatch marks for 100 and 200 guests. And the costs that we have are going between 200 and 3,200. So on the y or c of x axis, I'm going to count up by thousands. Now when I plot these 3 points, I have the point 0, 200, so 0 in the x direction, 200, so that's just a little bit above the axis here in the y direction. And then I have the point when x is 100, y, or c of x, is 1700, so that'll be just a little below 2000. And when x is 200, c of x is at 3200, so just over 3000. And you can see then that we can draw a line between these points. And looking back at the initial instructions, calculate some ordered pairs. So we have 3 ordered pairs, which we can indicate more formally by putting parentheses around them, separated by commas. So these are 3 ordered pairs, and then graph the function. We've plotted these 3 points and come up with a linear graph. And you can see that we're expecting a linear graph because as you look at this function here, we see that there's a constant and there is a variable with x, but the x is raised to the first power and is not second or third power, and that's what we would expect for a linear equation.